Hey there. Today we're going to gently pull back the curtain on something we all do pretty much every day, working with files online. We're going to explore the quiet, super organized world of server-side files. I mean, really think about that for a second. You hit upload on a photo or save on a doc, and it just, poof, goes off into the internet. But where is there? What does that place even look like? It might feel like magic, but it's not just floating around in some vague cloud. Your file is carefully placed inside what you can imagine as this huge, perfectly organized digital filing room. And this room lives on a powerful computer we call a server. Just like a real library, everything has its exact spot. Okay, so how does this all actually work? Well, the secret sauce is something called server-side scripting. These are basically special programs that have the keys to our digital filing room. See, unlike the stuff that runs in your web browser, these scripts run directly on the server. That gives them special permission to walk down the aisles, find the files, read them, and even create new ones. This is the invisible engine that powers almost every website you use. So, if we're in this giant digital library, how does a program find the one specific book it's looking for? It needs an address, right? A very specific one. And that address is called a path. You can see a great example here. This is what we call an absolute path. Think of it as the full step-by-step directions, starting right from the front door of the library, taking you to the right section, the right shelf, and boom, the exact file you need. But what if the program is already in the writing section? It doesn't need the full address every time. It can use shortcuts. The single dot basically means right here in the folder I'm already in. And the double dots mean go back one step or go up one level. They're just simple but super handy directions for getting around more efficiently. Okay, so our program has the address, but it can't just barge in and start messing with the file. Just like checking out a book from the library, there's a proper way to do things. There are rules of access. Now, this is a really important idea. When a program wants to use a file, it first asks permission. In a lot of programming languages, it uses a command like fopen function. And here's the cool part. The system doesn't just hand over the file. Instead, it gives the program a file handle. You can think of it as a temporary key or library card that's only good for that one specific file. And when the program asks for that library card, it has to say what it plans to do. We call this the mode. Is it just going to look at the file? That's R for read. Is it going to completely rewrite it? That's W for write. Or maybe it just wants to add a little note at the end. That's A for append. Being clear about your intentions from the start keeps everything safe and organized. So, the program knows where the file is and it has the key in its hand. Now it's finally time to get to work. Let's talk about the core operations. It all boils down to a simple three-step process. Step 1, you open the file. Here's what that looks like in code. We use our fopen function. We tell it the file's name, data.txt, and we say we want to write to it, using that W mode. The system then gives us back our temporary key, which we're storing in that $handle variable. Step 2 is where the action happens. Notice we're not using the file's name anymore. We're using our key, our $handle. We give that handle to a function like fwrite, along with the text we want to add, and it does the job for us. It officially writes our new information to the file. And please don't forget this last step, because it's just as important as the first. When the program is all done, it has to close the file, using something like fclose. This basically tells the server, okay, I'm finished, you can have the key back, this frees up the file so other programs can use it, and it keeps the whole system running nice and smooth. So far, we've kind of been talking about files as if they're all simple text documents. But of course, that digital filing room is full of all kinds of different things, not just text. Yeah, this really breaks it down nicely. On one side, you have text files, things like .txt files or even web pages. You can open them up and read them, just like a book. But on the other side, you have binary files. Think images, music, videos, programs. These are more like sealed packages of data, carefully structured for a computer to understand, not a person. So how does a program handle these sealed packages without breaking them? You'd think it would be super complicated, right? Well, actually, it's surprisingly simple. The program just gives the server a little heads up by adding a B to the mode. So R for read becomes RB for read binary. It's a tiny change, but it's a crucial instruction that makes sure the data gets moved around perfectly, bit by bit. The life of a file doesn't just stop at being read or written to. A good program also has to help keep that whole digital filing room organized. It's all about keeping things tidy.
For example, a program can ask the server, hey, what all is in this folder? It's like a librarian doing a quick inventory of a shelf. And what it gets back looks a little something like this, a raw list of every single file and folder with all the nitty-gritty details. This is how a program can see what's available before it decides what to do next.
And of course, a big part of staying organized is getting rid of things you don't need anymore. A function like unlink does exactly what it sounds like. It permanently removes a file from the server. This frees up space and keeps the filing room from getting cluttered. It's really the final step in a file's life cycle. So we've gone through paths and handles and modes and all these different operations. And it might feel like a lot of little details to remember. But if you just take one step back, you'll start to see a really simple and kind of beautiful pattern in all of this. And this, right here, is the key takeaway. The actual names of the functions, open, unlink, whatever, they might be different depending on the programming language you're using. But the core logic, the grammar of how you talk to files, is almost always the same. First, you open a connection. Second, you do your thing, operate on the file. And third, you close the connection. If you can remember that simple three-step dance, open, operate, close, you've pretty much understood the heart of how this all works, no matter what technology you're using. It's really easy to see all this as just cold technical stuff, but I like to think of it more like a quiet conversation. A program politely asks for a file, the server grants it a key, the work gets done, and the key is returned with a thank you. And it's this silent, elegant dance of data happening millions of times a second all over the world that really brings our digital world to life.